Hey, how's it going out there, guys? Got a great show lined up for you today. Again, if you'd like to support this channel, there are PayPal and Patreon links in the info box below. And I'd like to say hello out there to Betty, who's not going to be able to make it today again. You'll be back next week. I may have to consider garnishing your wages. And to the rest of the panel, what's up? What's going on out there? Not too many people in here today. Neil, what's up?
What's going on?
And Steve, how's it going, Steve? You're on candid camera, sir. That's what I thought. Cool. Getting off to a rocking start. Listen, this show is going to be on spectroscopy. And I was gonna do this a little bit differently. Usually with the presentations, I would go part of the way through, do it in thirds, halves, quarters, stop, give everyone a chance to go ahead and chime in and see what they thought about the subject. But today I was going to do it, and I thought about it earlier this week, that I would just go through the entire presentation, right? I'll go slow, not too slow, but slow enough, and have everyone that's on the panel, if they have any questions, comments, or concerns, to go ahead and pull out a piece of paper and a pen or a pencil and write them down, right? For you folks out in the audience, I'd like you to do the same thing. A little bit more interaction, get you a little bit more involved. How you guys like that idea? That's what I thought. I love it. Silence is golden. We may jump right into this. Let's wait till a few more people get in here. And I guess the mic's all mine. What are we going to talk about? Or you want me to sing? I'm going to be singing a dirge for celestial and astronomical spectroscopy here in a few minutes. I'll tell you what, folks. This is easier to debunk than evolution. That's how easy this is. And it's even more deadly. I couldn't believe it. After I went through it, I was looking at the presentation because I did this presentation 3 or 4 months ago. It may have been longer. And I went back to the presentation earlier this week and I said, you know what? I kind of missed a few things here that are so detrimental to this disheveled monkey. And I was just sitting there snickering to myself. But we're going to go over each of those, and you're going to see how this is a tear-jerking, belly-laughing train wreck. Now, I'm not talking about the discipline of spectroscopy. There's a difference between terrestrial spectroscopy and celestial and astronomical spectroscopy. Two different, completely different animals here, with the same name, by the way. That's how they get away with most of this nonsense, right? They're little linguistic word games. So we have like terrestrial spectroscopy, which is secretariat, versus a hairless, decapitated, road-killed platypus, which is celestial and astronomical spectroscopy. You see, in these crayon munchers try to get away with just using the word spectroscopy, and that's it. Voila, Bob's your uncle, right? No. That ain't happening. I'm going to tell you that now. Not on my watch. So, without further ado, hey guys, everyone in there, we're going to get underway. Everyone in the Hangout, I appreciate it if you mic discipline me. Keep your mics on mute until after the presentation's over. I appreciate that really a lot. No feedback issues. Get your pen and your papers out. And chat, sorry, I don't have chat pulled up. I'm not monitoring it. You can pile up the super chats in there and I'll get back to them after the show, or maybe next week I'll shout them out. If you'd afford me that courtesy, I want to pay attention to the presentation. All right, let's get into it. So we have spectroscopy. Well, let's define it. Basically, it's the interaction of light with matter, specifically with respect to emission and absorption of radiation. It's just that simple. The entire enterprise is based on the quantization of energy. Quantum mechanics. Everything is quantized. That is in discrete chunks. And this just, it's a slam dunk for quantum mechanics. You're going to see why here in a couple minutes. That's not the mission of this presentation, though. Each element has its own unique, distinct fingerprint, and it's governed by the number of electrons and their respective shells. Or what I like to call them, it's better to say is their energy levels. Because they don't have shells, they don't have orbits. Now you'll hear a lot about that, even in high school and undergraduate, they'll still call them orbits. They're not. But I digress. Here's a diagram. Like I said, don't worry about they have to put it in some diagram so you can visualize it. So what this is, we and all the elements endeavor to persevere to be in the ground state. Right? It's the lowest energy state possible. When I retired, I couldn't help but endeavor to persevere as best as I could, keep my feet up, hit the stogie, right, and relax. We all endeavor to be that way, the lowest energy state possible. However, what happens sometimes is we like to run marathons. We like to be active, but we can't stay that way forever, right? We always got to rest. Same way with the elements. So what happens is once these elements absorb energy, and it has to be a discrete amount of energy specific to each atom and their respective energy levels, which makes it really cool. And you can identify these guys by these spectra. What happens is these electrons in their outer shells or energy levels, they kick up into higher energy levels, right? They absorb energy. Easy way to do it, just heat up a piece of metal, right? It starts to get hot, starts to change colors, right? The more it's heated, the more energy that's put into it. These electrons kick up into higher and higher energy levels, like I said, specific to that individual element, right? So what they do is once they get up there, remember, they always endeavor to persevere to come back to the ground state. So what happens, these electrons, they fall back to the ground state, and by doing so, they release that distinct amount of energy into photons. No more, no less. From the excited state, they come back down to the ground state and release their energy. Simple as that. Okay? We're not going to get too much in depth with that. I think that explanation does it fine. We'll touch a little bit on this one, on hydrogen, just to bring out a point, little sidebar point here. And like I said, they call them shells or orbits. Don't worry about that. They're not. They're neither. But what happens here, what's really cool here, and this is the mission line spectra for hydrogen, what's really cool here is you can notice these are distinct lines. They're quantized. So you got hydrogen, if it kicks up, if the electron gets enough energy, it has to be a right amount of energy. It can't be right in the middle here, this amount of energy, because it's never going to get to that energy level. It has to be a discrete amount. If that discrete amount is reached, and that electron hits up into this energy level, right? Remember I said it's going to endeavor to persevere to come back down to the ground state. So what it's going to do is it's going to go from here to the ground state. However, and this is really cool, that electron does not pass through the space in between. It jumps from here back to the ground state. And it releases that amount of energy. How do we know it doesn't traverse this space? From the spectra. Because if it did traverse that space from violet through blue-green through red back down to the ground state, guess what you would have here? You guessed correctly. From the violet, you would have a smear all the way to the red. Ain't that cool? What they call that is the quantum leap. That is exactly what it is. So anytime you hear quantum leap, that's exactly what they're talking about. Any questions? Good. That's a little sidebar there. Very interesting. We're not going to spend any time on that. I just thought you'd find that interesting. Let's get to the mission. We're going to discuss spectra from spectroscopy. There are three main types of spectra: continuous, emission, and absorption. Right? Continuous, absorption, emission, right there for you. Dark line spectra is the absorption spectra and the emission spectra. Continuous spectra are produced by energized solids. Very important. Remember that. Continuous spectra are produced by energized solids. Plasma with some caveats. I'm not going to get into that today. Emission lines are produced by energized thin gases without a light source behind them. Absorption line spectra are produced by cool, thin gases with a light source behind them. Everyone following? I'll try to slow down. I might have went too fast through that. You got that down? We can always go back. If you have a question about that, just put continuous or emission and then we'll get back to it. Key learning objective. Gases only emit and absorb in bands. I say again, gases only emit and absorb in bands. Now to the principles. We have terrestrial spectroscopy versus astronomical or celestial spectroscopy. Terrestrial spectroscopy is atomic emission spectrometry and atomic absorption spectrometry. These guys up here. This is Secretariat. Versus a hairless decapitated platypus roadkill. Right here. Astronomical spectroscopy. And I'm going to show you exactly why and how. Here we go. Terrestrial spectroscopy, like I said, we have atomic emission spectrometry. That's flame inductively coupled plasma. Electrothermal, that's graphite furnace. This is very important. Inside a frigging machine. It's a closed system, highly controlled. You see this right here? This is an inductively coupled plasma atomic emission spectrometer. Remember that? Now, during the last presentation, I went through the inner workings in depth with both of these, both AES and AAS. I'm not going to do it today. If you want to know the inner workings of this, just go back to the initial presentation. Atomic absorption spectrometry. We have flame, cold vapor, hydride generating, and graphite furnace again. Guess what? Inside a frigging machine. It's a closed system, highly controlled. This is a flame atomic absorption spectrometer. Everyone got these visions in your head? This is how terrestrial spectroscopy is done. Closed system, highly controlled. And it's as right as the rain if you keep it controlled. Versus our hairless, decapitated roadkill platypus, celestial or astronomical spectroscopy. It's an open system and not controlled. So pretty much the exact opposite. All the unknowns and millions of potential confounding variables between you and the sun. This little photo's from the McMath Pierce Solar Telescope at Kitt Peak. Right? Everyone's got this. You get a visual on this, right? Take a look at this. Absorption spectrometry and emission spectrometry. Right? You guys got that. See the difference, right? Because that's an important point, wouldn't you think? because that's the first belly-laughing train wreck. I hope you see the elephant in the room problem. And it's only just one. We're going to get to many more below. So we got, again, actual spectrometry, atomic emission spectrometry, and atomic absorption spectrometry. It's in a closed system and highly controlled. Versus celestial spectroscopy, that hairless, decapitated, roadkill platypus. It's an open system and no control whatsoever. All this is, folks, another feebly contrived, clumsy Dunning-Kruger bait and switch. That's all this is. The clowns say spectroscopy, using the veracity of actual spectroscopy, terrestrial, to give credence to their fairy tale celestial spectroscopy via Elmer Fudd linguistic association with the word spectroscopy. All it is a simple doofus equivocation fallacy and a Mr. Magoo false equivalence fallacy. That's all we got right here. Number 2 belly laughing train wreck. From Foucault Peter Solar Astrophysics and Caltech via Wiki, astronomical spectroscopy is used to measure 3 major bands of radiation: visible spectrum, radio, and X-ray. While all spectroscopy looks at specific areas of the spectrum, different methods are required to acquire the signal depending on the frequency. Excuse me. Ozone, O3, and molecular oxygen, O2, absorb light with wavelengths under 300 nanometers, meaning that X-ray and ultraviolet spectroscopy require the use of satellite, telescope, or rocket-mounted detectors. Radio signals have much longer wavelengths than optical signals and require the use of antennas or radio dishes. Infrared light is absorbed by atmospheric water and carbon dioxide, so while the equipment is similar to that used in optical spectroscopy, satellites are required to record much of the infrared spectrum. So, since X-ray, ultraviolet, and infrared spectroscopy require satellite rocket-mounted telescopes, i.e., they need to travel into a second law of thermodynamics violation, aka telescopes in Narnia, they're file 13. Since our focus is on the sun, radio spectroscopy is also file 13. Section Summary. When the incoherent hordes of clinical-level Dunning-Kruger pretender clown Wiki Discovery Channel parroting, spinning ball-tard space monkey window lickers respond with spectroscopy or spectroscopy or spectrochocoloscopy or any of the 550 other nonsensical buffoonery spectroscopy that they can't even pronounce, when challenged with, "How do you know what the sun is made of?" you can now laugh uncontrollably in their crayon munching faces. I can essentially stop right here with the presentation and be done with it. But where's the fun in that, right? You ain't seen anything yet, folks. Somebody hold their beer. Evolution, you got a contender. Remember, key learning objective. Don't want you to lose sight of this. Gases only emit and absorb in bands. I say again, gases only emit and absorb radiation in bands. Number 3 belly laughing train wreck. From NASA. The spectrum of the sun appears as a continuous spectrum. Really? That's interesting. And is frequently represented as shown below, right from the document, folks. This type of spectrum is called an emission spectrum. Really? Huh. Because what you are seeing is the direct radiation emitted by the source. In case of the sun, light is emitted at almost all energies in the visible spectrum, which is why you see all the colors in the sun spectrum. Really, we see this when we look at the sun through a spectrometer, really. Unbelievable. You got a big problem, because this is the sun's absorptive spectra, brought to you by the solar telescope from Kitt Peak we observed above. How are we seeing this and this? Por favor. Question: how in the flying Fukuyama can the sun give both continuous spectra and an emission line spectra? Huh? Does the sun have its own no-atmo day too? This is shocking, folks. Right here, this is shocking. You need to get... You see, they confuse everything by their lack of precision. I don't know what they're doing. I can't tell their motivations. But the lack of precision here, it's revolting. Here we go again. Same document, same source. When the light leaves the surface of the sun, it is very nearly a continuous spectrum. Very nearly. Wait a second. You had something different to say up here, didn't you? Oh, we'll see that below. 1 second. I'll start again. I digress. When the light leaves the surface of the sun, it is very nearly a continuous spectrum. However, as it passes through the sun's atmosphere, gases present in the atmosphere absorb specific wavelengths of light. Yeah, like we talked about, remember? Gases only emit and absorb in bands, leaving the pattern seen in the spectrum above. Yeah, this pattern. The absorption line spectrum. Yeah. Not this pattern. Not this one that you put in your paper. No. By studying those lines and matching them to known lines from the elements, astronomers are able to determine what gases are present in the sun's atmosphere. Huh. Okay. NASA, can you make up your mind? Is it a continuous spectrum or very nearly a continuous spectrum? Please, we'd like to know. Unbelievable. And then next, this is absolutely lovely. Pay close attention to the words that are coming out of my mouth next. This is from Hernshaw, The Analysis of Starlight, Cambridge, and Francis Jenkins and Harvey White, Fundamentals of Optics, via Wiki. Listen closely. Hot, solid objects produce light with a continuous spectrum. Yeah, we already went over that above. Hot gases emit light at specific wavelengths. We already went over that above. Remember my key learning objective. Gases only emit and absorb in bands. Fine. And here's the rub. Listen closely. And hot solid objects surrounded by cooler gases show a near continuous spectrum with dark lines corresponding to the emission lines of gases. Yeah, like we just observed with the sun. By comparing the absorption lines of the sun with the emission spectra of known gases, the chemical composition of stars can be determined. Everyone see this? Do you see it yet? Let me say it again. And hot solid objects surrounded by cooler gases show a near spectrum with dark lines corresponding to the emission lines of gases. By comparing the absorption lines of the sun with the emission spectra of the known gases, the chemical composition of the stars can be determined. See the problem? Is a ball of hydrogen gas, the sun in a second law of thermodynamics violation, a solid object? Because that's what exactly they're saying here. Yeah, they're not explicitly saying it, right? But it's directly implied. It's the next sentence. My word. The tangled webs you weave. This is problematic, folks. This isn't the elephant in the room just yet, if you can believe it. Ladies and gentlemen of the jury, you're witnessing a convoluted gaggle screw of epic proportions. If it's not a solid, is it a gas? If so, then how in the flying Fukuyama are you getting a continuous black body spectrum from a ball of hydrogen gas? When, remember our key learning objective, gases only emit and absorb in bands. How's that happening? My word. Number 2, how in the flying Fukuyama are you getting a ball of hydrogen gas in a 10 to the negative 17 torr vacuum without bludgeoning the second law of thermodynamics to a bloody lifeless pulp. Huh? How's that happening? Same goes for plasmas here, by the way. Plasmoid boy. Now, if you thought all the above was a rootin' tootin' cluster gaggle of double speed corks puckery, then somebody hold these Baltard's beers. Pay attention to this, folks. From Lumen Learning, Spectroscopy in Astronomy. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun, absorbing those wavelengths of sunlight. Because the space between us and the sun is pretty empty, astronomers realize that the atoms doing the absorbing must be in a thin atmosphere of cooler gases around the sun. Now, I'll deal with this train wreck thin atmosphere of cooler gases here in a few minutes. What I would like to direct your attention to is the top line. Dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun. Give evidence of what again? Like they said, well, certain chemical elements between us and the sun. Excuse me, but aren't we attempting to find out what the sun is made of? Not the stuff between us and the sun? Por favor? Can somebody please tell me what in the flying Fukuyama is going on here? Please. If I'm asking you, if somebody's asking me what's between me and the Atlantic Ocean, or what is the Atlantic Ocean made of, I'm not going to tell them what the stuff is in between me and the Atlantic Ocean. Okay? Just not going to do that. Because that's not paying attention to the question. Ladies and gentlemen, oh my. Take this in. Let this marinate. We're going to get back to that. I can't leave that go. Not only begging the question, this has so many fallacies and it's unbelievable. Let's deal with it. Listen. In a couple minutes, we're going to listen to Professor Vaught from New Mexico State discuss a similar scenario that's depicted here. But I wanted to take a few ICBM shots at this disheveled monkey. Disregarding the second law of thermodynamics, fairy tale gas clouds in a vacuum, and an abject train wreck foobar that I'll get to here quite quickly. Let's take a look at how the three different spectra are acquired. Continuous, absorption line, and emission line. Like I said before, continuous spectra are produced by hot solids. See this? It's funny they put a light bulb here. What they're trying to depict here, which is freaking hilarious, is the sun, right? Don't let that fool you. But why in the world did they put a friggin' light bulb here? I don't know. So, back to continuous. There's no intervening atmosphere or gases between the numpty and the continuous light source, which is a solid. Because, like I said, it has to be the sun that they're going for here. Well, this is a filament. Back again to, is the sun a solid? With the little Joseph Goebbels depiction here? I digress. This is tear-jerking belly laugher, folks. We also have an absorption line spectra and an emission line spectra, right? You have the fairy tale gas cloud, second law of thermodynamics here, between the numpty and the continuous light source. And over here on the emission line, You have the light source exciting these gases in the second law of thermodynamics, so this fairy tale gas cloud. But you get the principle, right? Remember, gases only emit and absorb in bands, the absorption lines and the emission lines. But we could let's disregard the continuous over here to the left and the emission. We're not really all that concerned with. Our emission is the middle guy here. So we have a numpty. 8. We have the sun, or our light bulbs in space. And between the two, we have a second law of thermodynamics fairy tale gas cloud, right? I got a few scenarios here that I want to put forward. Let's see how it shakes out. Scenario number 1. The white light source right here is 93 million miles away, and the cool, thin gas cloud, the second law of thermodynamics fairy tale right here, that's only 90 million miles away. Are you getting the same absorption line spectra? Yep. Scenario number 2. The white light source is 93 million miles away, and the cool, thin gas cloud, second law of thermodynamics fairy tale, is 50 million miles away from the numpty. Are we getting the same absorption line spectra? Yep. Scenario number 3. The white light source is 93 million miles away, and the cold, thin gas cloud is 10 million miles away from the numpty right here. Will the numpty get the exact same absorption line spectra depicted here and in the previous 2 scenarios? Yep. Scenario number 4. The white light source is 93 million miles away, and the cold, thin gas cloud, second law of thermodynamics violation fairy tale here, is only 3,000 miles away from this numpty. Are we getting the same absorption line spectra that we got in the 3 previous scenarios? Por favor? Yep. Yes, sir. Yes, ma'am. We are. Kablooey? Perhaps? Unbelievable. Let's get back to the cool, thin gases around the sun. My first question, friggin' where? The photosphere, what they call the surface, and by the way, gases don't have surfaces, is said to be 5,700 degrees Kelvin. The sun's atmospheric layers, that is the chromosphere, is said to reach 500,000 Kelvin and is 10,000 kilometers thick. The corona is upwards of 10 million Kelvin and 5 million kilometers thick. Is this describing cool, thin gases? If you think so, I think you have bigger issues, deeper-rooted issues, than whether the Earth is flat or a sphere or not. And by the way, if you noticed, this 5,700 Kelvin to 10,000 Kelvin to 5,000 or 500,000 Kelvin to 10 million Kelvin, if you notice that inside the sun it's 15 million Kelvin, that's all a second law of thermodynamics violation, by the way. Separate second law of thermodynamics violation. Here we go again. This is from Rochester Institute of Technology. Really vague right here. Thin gases emit light of only a few wavelengths. Now, thin excited gases emit light only of a few wavelengths, Rochester. We call this an emission or bright line spectrum. Yeah, they have to be excited to emit light, for goodness sakes. If there is a source of light behind it, a thin gas will absorb light. Yeah, a thin, low energy gas, or it's not. It has to have everything in the ground state, right? To absorb, to give the electrons or afford the ability for them to go up into a higher energy level. So this is pretty vague. We call this an absorption or dark line spectrum. Yeah. Okay. So back again. The chromosphere is said to be 500,000 Kelvin, is 10,000 kilometers thick. The corona is upwards of 10 million Kelvin and is 5 million kilometers thick. The atmospheric layers of the sun are cool or cold? How about thin? Is this all lining up? Is this speaking to you guys? Doesn't appear so, does it? Now, let's allow Professor Voigt from New Mexico State University to speak to this issue and hammer my points all the way home. Let me turn her up. About right there. That should do it. Let's try that. Without further ado, Professor, here we go.
So now that we have the idea of colors going through the spectrum, and of a larger spectrum that contains colors of shorter wavelength or of longer wavelength than the human eye can see, we're going to take those ideas and apply them to spectra, figures or plots showing the dispersed light spread out as a function of wavelength, and we're going to consider the astronomical applications of spectra. So we begin by building on the atomic theory that we developed last week. We know that a given atom of some species will absorb and emit energy at the same frequencies. So if it absorbs a photon at a particular frequency and has an electron jump up one or several energy levels, inevitably it will emit the same amount of radiation when that electron decays down towards the lower or ground states within the atom. A cool gas of hydrogen atoms, for example, will produce an absorption line spectrum if it lies between you and your telescope and a continuum light source. So let's think about this and develop this picture a little bit. In our first diagram, on the left we have a white light source, something that emits smooth continuum radiation at all frequencies, and then we have a gas cloud, which is much cooler than the star and is filled with atoms, represented as small circles within the cloud. Our white light source, if observed directly, would produce continuum radiation at all frequencies. But what happens if we look at the star through the cold gas cloud? We know that the cloud is full of atoms. When we say that it's cold, we mean that the atoms contain electrons that are in low energy states, which would just love to jump up to higher energy states. So we see colored beams of radiation coming from the star in all colors, meaning that it's emitting light at all wavelengths or all frequencies. Those photons, which contain exactly the right amount of energy to enable electrons in the gas cloud to move from energy level to energy level, are the ones which are absorbed by the gas cloud atoms. So when we look at the star through the gas cloud, we see a continuum radiation source with light preferentially removed or absorbed at those key frequencies. So this is like a fingerprint. Once you match up the wavelengths that are missing from the continuum spectrum, you know exactly what elements were present within the cloud. Now you may wonder why the radiation is missing from the beam of light emitted from the star when you know that the atoms in the gas cloud will be excited and then de-excited. Let's think this through carefully. The electrons are elevated to a higher state within the atom, and then, given a little bit of time, they decay back down to the lower energy states. So in essence, all of the atoms in the cloud are absorbing and then re-emitting the energy which they take from the star. If that's the case, why doesn't that energy just fill in back the holes in the continuum spectrum, causing us to see a perfect continuum spectrum in our telescope on the right? The answer is very simple. Once an atom absorbs a photon, it loses all of the information about the direction in which that photon was traveling. The electron absorbs the photon, takes that energy to climb up to a higher energy state, and then when it falls back downwards, that photon is re-emitted in a random direction. This is the key point. And the result of this is that the gas cloud emits that radiation isotropically, meaning in all directions. It doesn't send all of the photons back along the beam of the star in the direction in which they were traveling before they were absorbed. Instead, they get scattered in all four directions to the winds. We can see this by placing another telescope, one that only looks through the gas cloud but that does not see the star. Imagine that the star and the gas cloud are separated by quite a great distance, as are the telescopes, so that we only see very narrow beams. Much as when you look up at the sky, one individual star only covers a very small angular distance on the sky. Now with our second telescope, when we look straight through the gas cloud, what do we see? Well, if there's no strong source of radiation present, if there's no star, we don't see anything. The cloud is cold, remember, and what that means is that it's not emitting energy on its own. The situation gets more interesting when we add back in the source of continuum radiation on the left. Once we do that, our gas cloud has a ready source of energy. It starts to absorb photons and re-emit them, and because it's re-emitting them in all directions, some of them are going to fall into a line that points to our second telescope. We don't see the continuum radiation from the star that passes through the gas cloud. What we see is only the radiation re-emitted by the cloud. So what we see now is an emission spectrum. At most wavelength, there's no energy whatsoever. But at a few key wavelengths, those that correspond to the energy levels of the atom within the gas cloud, we have extra light. If you combine this emission spectrum with the absorption spectrum that we get by looking at the star through the cloud, the combination, in effect filling in the holes in the absorption spectrum with the emission spectrum, leads us to the original continuum spectrum. Light may be divided into two paths, but it's neither created nor destroyed in this process. It's a very elegant process.
Thank you very much, Professor Vaught, for hammering my points home. Remember, gases only emit and absorb in bands, right? These are in bands, dark line versus emission line, right? Let's go to the conclusions, shall we? Number 1. Belly laughing bait and switch equivocation fallacy, terrestrial versus celestial spectroscopy. Remember, we have Secretariat versus a hairless, decapitated, road-killed platypus, celestial spectroscopy. Number 2. NASA is unsure whether they're getting a continuous or absorption line spectra from the sun. Number 3. These bozos, that's including Weeke, Hernshaw, J.B., Francis Jenkins, and Harvey White, think the sun is a solid. And number 4, my favorite. I mean, yeah, that's pretty funny right there. But this is my favorite by far. The dark line, this is from Lumen Learning, Spectroscopy and Astronomy. The dark lines in the solar spectrum thus give evidence of certain chemical elements between us and the sun, absorbing those wavelengths of sunlight, because the space between us and the sun is pretty empty. Astronomers realize that the atoms doing the observing must be in a thin atmosphere of cooler gases around the sun. I don't really care about this because we already pummeled that. But between us and the sun, I say again, give evidence of what? Well, like I said, certain chemical elements between us and the sun. But I was under the impression that the question was, what is the sun made of? Not the stuff that's in between. That's kind of a non sequitur red herring fallacy from the Black Lagoon, isn't it? Because we're asking you what the sun is made of, not the stuff between us and the sun. You get it yet? Baltards, do you get this? Unbelievable. Can somebody please tell me what in the flying Fukuyama is going on here? I don't know, ladies and gentlemen of the jury. With astronomy or astronomical spectroscopy and celestial spectroscopy, the emperor not only has no clothes, there is no emperor and no clothes. Thanks for your ear. Have a nice day. Well, let's see who we got in Discord. Hey, I appreciate you guys going on mute. I didn't hear a single reverberation. What's going on? Adam, the Adam Meekin, sir. What's up?
Evening. Sorry I was late. I was just grabbing my tea. I was actually trying to see what I was going to have, John. So I was looking between me and the kitchen, and I could see grass and chickens. So I was thinking that's probably what my tea would be, but it turned out to be leek and potato soup. So yeah, no use looking at the stuff between it.
Yeah, obviously you got it, right? Hopefully, I want everyone to get that. Do you think do I have to go over it again?
I think I summarised beautiful with my tea analogy.
I thought it was too, boy. Yes, sir.
All right. it's a shocker, isn't it? It's worse that we know the sun's hot, but we can't actually live with that. And we've described how thick the layers are, but that doesn't fit with what we want it to do. So we'll have to then say that there's a cool thin layer around all of that, which I'm assuming they mean is it's come from the sun. Just fell off so that the light could go through and be analysed, sort of thing. Is the only thing I can think. It's such a frustrating set of contradictions when you look at it. To hold their religious belief together, they've got to deny their own statements of truth.
I don't know. What did they think, that no one would look? I don't know. That this, like I said in the beginning, this I can pummel this easier than pretty much anything I ever ran into, including evolution, which was quite easy. But this is a big, hanging, watermelon-sized curveball of epic proportions.
We're measuring hydrogen and helium here, I assume, is the main bands that are pointed out. And what I'd kind of say is that unless you believe in the medium of space and they've stuck a telescope in there to replicate that rather technical diagram the professor put up, then I just point out that at upper layers, even in their own rhetoric, it's just hydrogen and helium. Certainly if you're using any land-based telescope or even one mounted on an aeroplane, you're still going to encounter, like I say, it doesn't matter whether it's 1 mile from the sun or 1 mile from you.
Exactly.
The emissions.
Exactly. Yes. Got it, sir. This is a train wreck on so many levels. I don't know. I'm at a loss for words here. This is so stupid. The juxtaposition or the similarity between, a valid, verified discipline such as spectroscopy, and then you get this disheveled monkey, the road-killed platypus, celestial astronomical spectroscopy. Why isn't there more people like spectroscopists burning down the houses and the bridges? Why is that? I have never heard that, besides Dr. John, the last time we did this. He's the only one I ever heard object. Why is that? Are there no actual spectroscopists out there? Does anyone know a spectroscopist? Can you have him get in touch with me? I'd appreciate that.
I reckon probably the real ones and then the celestial ones, they probably keep them apart at the Christmas party, so they can't.
Adam, have you ever heard any spectroscopist other than Dr. John D, say anything about this, whether it's in the literature or things that you heard through the grapevine, anything, any objection?
No, John was he's incredible. He was quite appalled at it, wasn't he? When he describes the pain and effort that they have to go to isolate things, to sample them.
Sure.
I do need to correct it. It's spectroscopy, by the way. The way you were saying, to isolate it with I think a while ago, wasn't it, when he showed you the equipment he used and, the isolation that's required to give you any kind of validation in the result. It's all right. Just have a look up. It will tell you what the sun's made of. But yeah, no, it was his, and his description of the detail and the effort that he went to in his PhD and stuff like that, when he's using this, and how easy it is to knacker any results. Does make a little mockery of trying to pretend you can just turn that equipment to the skies and get the same level of inference from your results.
It's not even the same equipment, right? Because the equipment is in a closed system, highly controlled, versus the solar telescope at Kidd Peak. It's the direct opposite of everything that stands for.
Yeah.
Oh my!
I think
like
he
I
said it'd be the same as like taking the end off the machine, wouldn't it, in the lab, and then saying, yeah, the results are just the same.
Yeah. I didn't think about that. Yeah, I got a visual with that. That's pretty funny, Adam. Unbelievable. I can't believe it. Ladies and gentlemen, I'm at a loss for words. I don't know how. I don't think language can even get close to adequately encapsulating the it's tomfoolery. Horsepuckery. I can't do it. I don't have the words. It's too stupid. I don't know, brother.
I think tomfoolery is more the point. It is you say there, they got bait and switch.
Hey, shout out. Hey, 1 second, Adam. Shout out to Cruel Vision. I appreciate that. He said masterful presentation. Thank you, my friend. Yes, thank you. Appreciate that. Yeah, I enjoyed doing it. I have to admit, this was one of the funnest presentations. I had a good time with this. This always happens too. When you go over a subject in depth and then leave it go for a while, I can only speak for myself. When you go over a subject really in depth and you leave it go, and when I come back to those subjects, I always get more insights, and they come really fast. It's always happened to me that way across a wide venue for some reason. But they start just jumping off the presentation to me, and I was like, did I even talk about this the last time? I think we did a little bit, but I don't think I stressed them enough. So, hey, I appreciate that, A Cruel Vision. Thank you very much. Go ahead, Adam.
No, I was good. I was there the last time. I think you were less interrupted this time, John.
Yeah.
I heard it. I'm like,
Don't take that personally, Adam. I didn't do this. I was thinking about doing or conducting presentations in a similar way. Now, the longer presentations, that's going to be a little bit more difficult because, I need a break, drink of water, relax for a couple seconds before moving on to the next topic. But I looked at this presentation, I said, you know what? Maybe it'll be better if I just went through the whole thing without any breaks. So everything would be more or less, there would be a lot more continuity and consolidated. I don't know. I'll have to look at, I'll look at the presentation, how it came across over video, and then ask people out there for their opinion of it and go from there. What's that, sir?
It covers the topics well, John. Actually, it probably is better off just concisely done because it does all hold together as one. And because there are so many frustrating incredible spots, I think I do remember us going sideways quite a fair bit.
Yes.
So it is good to keep it concise.
Well, I almost went sideways in the beginning. This is prime territory to go sideways. Well, number one, because it's an interesting subject. Number two, there's so much tomfoolery in here that you'd be remiss to not at least touch on it. And then everyone sees it, and then everyone got their take on it. This is just prime territory. And most subjects in this genre it's easy to get off track, right? Because it's always connected to something else. And there's another point with that other thing. And then before you know it, you're talking about tea across the spillway. Too funny, man. Let's see. Listen, Arwen, you came in here and you deaf and muted yourself about an hour and a half ago. BG, Any comments, concerns, questions?
A lot of questions.
Hold on a second. Let me turn you up. Try it again.
But I got a lot of questions. This is the first time I'm hearing about this. I'm just listening.
Okay. Hank. 1 second, Hank. Hank Kill, sir. Old timer Hank Kill. Go ahead, sir. Huh. He's stonewalling me. All right, Hank. Go ahead, Adam. Give him what for.
Oh, I'm just going to say, you're getting blank, mate. So. Asking what's peeping.
Hank, what's peeping, brah?
Yeah, what's up?
Oh, that did it! Any comments, questions, concerns with the spectroscopy presentation?
No, sir. To be honest, I missed most of it. I was working. I do apologize.
No, that's okay, man. I totally understand. Cool. Yep. Neil. Neil, you came off mute and I don't hear you, man. Drop out and come back in again. Yeah, your mic's not working. We'll wait a second for Neil. I know he's got something to say. Go ahead. 1 second, Neil. Are you? Yeah, you're off mute, sir. Go. Neil, here, let me try it. Maybe this is.
You talking to me?
Yeah, I was gonna say, what's peeping, bro? There you go. Go ahead.
Are you talking to me?
Yes.
Okay, well, good. We're in like a tornado watch here, so.
Oh,
batten
really?
down the hatches. Yeah.
Okay.
Upstate New
All
York.
right. Tornado
I'm
watch in
listening.
New York?
Well, upstate.
Oh, that's right. You got the tropical storm headed. I forgot about that. Yeah. Okay, I got you. Well, keep your butt down, man.
It's
Good.
down.
Good enough. Thanks. Dave Rakia. I know you got to be on mute, sir. Oh, no, you're not. There you are, sir. Sorry about that.
Yeah, hey, what's up?
What's up, man?
I was just texting my daughter about fishing this weekend. Learning about light, what the sun is.
Yes, you are. Did you get a chance to check the presentation out, man?
I heard about half of it, and the bad thing is I came about halfway in, so I got to go back and listen to it.
That's all right. Yeah,
It's
go
something
back
you
and
probably
listen.
got to listen to a couple times anyway, you know?
Yeah. But I think this one is a slam dunk. If I do say so myself. I think you listen to the first one. This will just be a review, but make sure you listen to it because you're going to get these crayon munchers talking about what the sun is, right? And then what they're going to say. And most all of them do what they do. One word, right? Spectroscopy.
I can't say it or spell it. I don't talk about it much.
Yeah, but it's their huckleberry, man. I loved that the last time I did this presentation, like 3 or 4 months ago, I didn't hear a peep about the sun for like weeks and weeks and weeks because I travel all around the various venues and just listen. I did hear about a week and a half ago there was a load of baltards in this hangout talking about spectroscopy. And I was just sitting back, laughing my hat off at these idiots. They didn't know what they were talking about, but they pretended they knew. They didn't get to any depth whatsoever. They don't even know what light is. Oh, boy. Too funny. Yeah. So I said, oh, it's about time. I'm glad I heard that because that gave me the idea to go ahead and do the presentation again. So this is for you. This bud's for you. Ball-tard spinning space monkeys. How you like me now? Anything else, Dave? I guess not. Oh, there you go.
No, keep crushing, man.
Appreciate it, Dave. Thank you. The pressed on, sir. You better have a good mic. You're off.
I think
mute.
we're doing all right. What's up? Appreciate you letting me listen. I like the slang of the open system without controls versus the nice closed system with controls. Contrast.
Yep.
It says a lot. I wonder if there's any wiggle room for even assuming the sun is a white light source or whatever. But maybe I'm just being stupid on that. But yeah. They're too busy worrying about the variables in the middle while trying to talk about the target behind. It's very interesting.
Isn't that very interesting? I hope everyone gets that clue. And when one of the baltards say spectroscopy, you got them. You got them dead to rights because they have no clue whatsoever what they're talking about. The experts don't have a clue what they're talking about. So the baltards, the rank and file guys, they're definitely not going to know. Just have a little cheat sheet. Go through this presentation. Make yourself a little cheat sheet. Because there's only 1 or 2 points that you need. You don't have to go through each one. Just 1 or 2 major points. I would suggest that last one about what's between you and the object, or what the object is that's far away and you're trying to figure out what that is. But that's not what spectroscopy does. They find out what's between you and that object. So I would definitely use that one. And then the solid, the sun as a solid, I would definitely use that too. That's pretty funny. That's just me, though. I usually start at the beginning because I really want to embarrass them. I'll start at the beginning and ask them. I'm not going to say what I'm going to do. I got too many itching ears listening. You just wait. I'm going to start bringing that up in the arena. I think I started it a couple days ago. We didn't get too far into it because we got sidetracked, but I think I'm going to head back that way again. So, appreciate it. Pressed on. Anything else? Well, thank you, sir. Appreciate that. Adam.
A final thought.
Final thoughts, sir, and take us home, man.
Oh, hey, yeah, I mean, great one again. A great one at highlighting this issue. It's. I love the bait and switch up there. That's exactly what this one is from. Whereas you look at the gas pressure and an atmosphere next to a vacuum, that's a straight contradiction we can see, and that they argue it and do it, but this one's fundamentally different in the way that they're trying to mug you off. They are trying, as I said with my tea analogy, trying to tell you that I can see what I'm going to have for my tea by really looking at what's between me and my tea and identifying every single thing between me and my tea will tell me what my tea will be. It's very normal.
That one really drove home with you, man. I could tell. That's outstanding. I hope everyone gets that. It's like shooting hippos in a fishbowl, people. Make them say spectroscopy. Ask them the question. Start it off. You initiate. Oh, man.
That's the crumb one. Make them say spectroscopy.
That's the first hurdle. That's the first obstacle they need to overcome. Except most can't. You know what? This has been so much fun. I might do this next week. Do it all over. Maybe do it like for the whole, have spectroscopy month. Right? I don't know, man. I'm just fooling. I might do that's, you know what? That's not half a bad idea. All right, Adam, any channel shout outs, anything you got?
No, obviously support the guys over Iron Realm. I might be popping on Roxanne's Really Woke Roxanne this evening. You see me there, and hopefully I'll be about Paul Buster's and on Nathan's. I'll try and get there on a Thursday if I've got an afternoon off.
Yeah, I know.
That, now you know where I'm at, and I'm trying to get into that I went in again. It get frustrating. I need to be able to speak. You got to be able to butt in sometimes. I can be polite, but very frustrating sat in there, not being able to speak, but in the Colosseum, mate. But I've been hanging around there listening in. One started last night, so yeah.
And I noticed that, Adam, and you're such a sweetheart. I don't think the arena marries up with you because you're too sweet.
Gotta get angry.
You should see me when I get angry.
Yeah, I have, and look out. But that's not the normal. That's not your normal state. That's an unnatural state for you. And the arena is so aggressive, right? And everyone tries to talk so fast. That's the opposite of you.
Well, try to slow down. You might get listened to a bit better, mightn't you? If all you're trying to do is get the words out, irrespective of whether people comprehend it, then. But I mean, I'll be great. I was listening. The guys over there, the mods, I think Jedi last night was pretty cool, and it's interesting what they're coming in with. So that's why I'm more interested in listening, John. Not necessarily diving in, but there are times where you want to go, oh, particularly when it's a free for all. So,
yes. Cool,
man.
Yeah. I like you being over there. It's like a warm blanket when I see you in there. It's like I know, I can tell every time you cringe.
It was particularly cringeworthy last night. I'm not sure who it was arguing that the star rotation wasn't east to west.
Oh my goodness!
So it was left and rights, and it was back to that. But it was. I think the guys developing the rules for warnings and stuff. It was it was just the baller coming in with objection. So I think they've got a good set of rules over there that they're firming up, and it's definitely going to facilitate much better actual progression in the debates. Even though last night was
that was the topic of the night, though, right? There was like 6, 7. Maybe I left. I got so frustrated with it because it's like a second grade, incoherent subject to resolve. I figured it's easy to resolve. It's so easy, and I got really frustrated because I'm arguing with the adults because essentially these adults are saying that instead of the sun rising in the east and setting in the west, they're saying the sun's rising in the west and setting in the east. I'm not kidding, folks. They may not say that exactly, but that's what they're implying. They don't understand that. And I just got frustrated. I said, I'm out of here.
Oh, they claim victory.
And then claim victory. Yeah, I don't want to go down that road. Let's go ahead and finish up. Adam, anything else?
That's well. I mean, I've just seen Nathan in the chat, and as he's not here, I suppose jump over to Nathan Oakley channel later. There'll be Earth debate.
Yeah, does he have a show? I'm not looking at chat right now. Ask him if he's got a show.
You got a show, Nathan? I assume so because I assume he turned up in chat to spam it. That's what I thought I'd save him a job, but I would assume so.
And remember, Nathan is ace. All right, sir. Anything else? Yeah, I got you, Adam. Appreciate it. Hey, thanks to everyone that joined the panel today. We're a little bit thin, but not lacking substance. So, take no prisoners. No quarter will be asked. None shall be given. And remember, I'll be back.